understanding of how to set up the problem. The second thing is, if you did not put zeros as placeholders, if you do not have zeros up here, that automatically is an 85, because you have got to have zeros to do the procedure correctly. So if you did not, it's a conceptual mistake. It's not just a simple math mistake. Here's what simple math mistakes would look like. You just added wrong somewhere and it messed up everything behind it. But you knew what you were doing. You set it up correctly, but you got a negative off or you added wrong. That's a 95, okay? The second thing that would make a 95 is if you do not put the plus sign before the remainder fraction. If you have no sign there at all, it is not a 100, even if everything else you got was correct, okay? So that would be a 95, because it means something different if you don't have that plus there. And then the reason why there's two answer forms on B is because the remainder was negative. So if you wanted to be real consistent and still write it in plus form, it'd be plus a negative 6 over x minus 3, or you could just do minus 6 over x minus 3. Okay. Bless you. Any concerns about how to grade? All right, please put your grade on there, make sure your name is on there, and pass those back. Students in the back, thank you ahead of time for putting those on my desk. Yes, ma'am. Okay, do you remember one day last week when I said that from here on out, the lessons are all going to look real similar, and it was going to be hard to keep things straight, like how one was different from the other? That kind of begins here today. So if you hear me repeating some stuff over and over and over, it's because we're going to be using synthetic division so much that you're going to go on autopilot with it. You're just going to do the math and look for whatever we're looking for that day. But I really want you to try to remember the reason behind what we do from day to day and the concepts. So that's why if I repeat myself to your annoyance, that's where it's coming from, okay? And here's where it begins, where I over talk about this word factor. That moved. I meant to underline it. That wasn't supposed to happen. So this word factor is both a noun and a verb, right? This problem is asking you to factor that expression. That's a verb, right? It's telling you to do something to it. But once you get that answer, what you've done is broken it up into factors. Those are nouns. An example of what that would look like without the x's in there, like just a little baby math problem, would be the number 15. If I wrote this as 3 times 5, I have factored it. Its factors are 3 and 5. You following me on that? Because what factors are things that are multiplied together. So factoring 15 gives me 3 times 5. 3 and 5 are factors. So over here with the x's in, what we're trying to do is, just like 15, I broke it up into something times something. The 3x squared plus 2x minus 8, I'm trying to break it up into something times something, but it's going to be something in parentheses times something else in parentheses. And if your answer to the problem was x equals, what did you get? Negative 2? Negative 2 3/4? You've gone too far. Because the problem did not ask you to solve, which is what you've done if you said x equals something. And so here's what you actually had to do, and you would have stopped at what I'm about to show you, okay? So I saw in your papers, you did your cross method. You had negative 24 up here and 2 here, and you said 6 and negative 4. And if you did grouping, you did your grouping magic from here, and you were probably fine because you're all really good at grouping. If you did swing method, what is the mistake that swing method people make usually right here? They forget to do what? That's right. They forget to divide by the 3, by the a value. And so right here, after you divide, if you can't simplify, you don't. But 6 over 3 simplifies and becomes 2. And what we do with that information is create factors from it. Now, if I were to solve, if the problem had asked me to solve, this would be perfect form, because I would do insiders lie, and I would say x equals negative 2 and x equals 4/3. 4/3. But it did not ask me to solve. It said to factor. So I'm not actually going to do x equals blah, blah, blah. What I am going to do, though, is the swing part of the swing method, where I take this 3 in the denominator and I swing it back up front. And this is the answer you should have if the problem asks you to factor something, okay? What word would you be looking for if your answer was going to be -2 and 4/3? What's that word? It'd be asking you to do what? Solve. That's right. It'd be asking you to solve. So this is factored form. And here's what's going on. Remember again, factors are things that are being multiplied together. So let me show you what's not factors here. X is not a factor. 2 is not a factor. Because what are those two things in relation to each other? What's that operation right there? What's between the x and its addition, right? So those aren't factors because they're not being multiplied. 3x is not a factor. -4 is not a factor. These are the factors. This entire group is one factor, the x plus 2 taken all together. And this group is a second factor because x plus 2 times 3x minus 4. It's a multiple. That's where the multiplication is, okay? So the first group is a factor. The second group is a factor. And just like over here with the 15, when you multiply the two factors together, you get back what you started with, right? 3 times 5 is 15. So if I multiplied these two factors together, what would I get? (3x² plus 2x minus 8). Perfect. So keep this in mind for just a second. Okay, so that's multiplication. Okay. What's the opposite of multiply? Divide. And so we can talk about this even further in the reverse direction. So take 15 again. 3 times 5, those multiply to 15. If you were to divide by one of them, if I did 15 divided by 3, what would I get? The 5. If I were to do 15 divided by 5, what would I get? The 3. Same thing over here. If I were to take this entire thing, that red stuff, divided by 3x minus 4, what should I get? X plus 2. And if I took 3x² plus 2x minus 8 and divided it by x plus 2, what should I get? The 3x minus 4. So if you look at that next problem on your notes, that's exactly what we're going to do. But we're going to use synthetic division to prove it to ourselves, that we would, in fact, get 3x minus 4, right? And then there's something special we need to talk about after we do that. So what number am I going to put in my little box to -2, right? Because when you're given the factored form, you want to use the 0 of it to start your synthetic division. So go ahead and do synthetic division here. Is it missing any x terms that you need to put a 0 for? No. Did you get 3 and -4? Okay. We were looking for that, right? Okay. If you were to add your x's back in, it started with x², so adding x's back in, you'd have to start with which x? X to the what? To the 1, right? And so that would give us 3x minus 4, which we already knew. And so here's the special thing I need to bring your attention to. What's the remainder here? 0. That is not an accident. Anytime something divides evenly into something else, you get 0 for a remainder. So if we went back to the 15 and the 3 and the 5, 3 divides evenly into 15. It's a factor of 15. Therefore, the remainder is what? 0. Right? You get 5, but with nothing left over. What's the remainder if you did 15 divided by 5? 0, right? 5 is a factor of 15, therefore the remainder is 0. What about if I did 16 divided by 4? What would the remainder be? 0 again, right? You get 4, the answer is 4, but the remainder is nothing because it goes in evenly. So 4 is a factor of 16, therefore the remainder is 0. Same thing here. X plus 2 is a factor of that, therefore the remainder is 0, which you can show easily by synthetic division. And so that is the goal of the lesson for today. You're going to be given expressions, blah, 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 blahs, right, with lots of x's and stuff. And then you're going to be given a divisor, and you need to check if it's a factor or not, right? And if it is a factor, it'll have a remainder of 0. What kind of thing would we expect to see here if it's not a factor? What would be going on there? Anything that's not 0. Exactly. Anything that's not 0. So here, so this right here, so everything I just told you, that is the factor theorem. This is what it looks like in mathy language. Do you want to go over this? No? Okay, excellent. I thought not. No one else today has wanted to, but it's good to give you choices. So here we go. Here's our first example. We want to know if x plus 4 is a factor of this, meaning does this divide evenly into that? If it does, it should have a remainder of 0. And synthetic division is a really, really easy way to find the remainder. But my first question for you is, what number goes in your little box? -4. And is it missing any x terms that you need to do zeros for? No. Okay. So go ahead and do A and B for a moment and see what you come up with. What's going to go in your box for B? +2. All right. Go ahead and do that for a few moments. So x equals -6 is a 0, or a root. It comes from the factored form x plus 6, right? And we're going to talk more later about going between those two forms. The thing that you need to know right now is, when it's in that form, what number do you put in the box? -6, right? You do not have to change the sign when it's already given to you in 0 or root form. And is it missing any x's? No. Go ahead and do the next two problems. The second one has a fraction. I encourage you to work with the fraction. You know, you're the boss of the fractions. Don't let them scare you. However, if you are a little bit scared of the fractions, you can convert it to a decimal if you must. But I think you should do the fraction. Who got yes for the first one? Excellent. Here's the math if you did not and you just want to check yourself real fast. And then I'll give you a minute to finish the next one with the fractions, because I'm confident you're trying to work with the fraction. Spoiler alert. Don't look at the board until you're done, because I'm going to do the work, and I'm also showing the fraction work. Don't look till you're ready to look, because once you look, you can't unsee what you have seen. So the answer is yes, right? If you did the fractions and you did not get 0 for your remainder, I put the work up here so you could check yourself and see where you went wrong. If you converted to a decimal, I anticipate you did not make any mistakes at all.